Hello, and welcome to Inverse Trigonometric Functions, Differentiation. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. This calculus lecture comes to us from Chapter 5 of Larson's 11th edition calculus text, Section 5.6, Inverse Trig Functions, Differentiation. If you need a refresher on inverse trig functions, please check out my pre-calculus video. Should be Math 1508, so it'll be called 1508 Sec 4.7 Inverse Trig Functions. You can get them in my in notes form at my UTEP website. Just Google UTEP Math and Tuesday. It'll pop up for you. It should pop up for you. But the videos will work also. So let's get to it. The derivatives of inverse trigonometric functions. Let u be a differentiable function of x, as we always let happen. Then the derivative of the arc sine, right, the inverse sine of u is the derivative of u over the square root of 1 minus u squared. Notice the derivative of arc cosine, exactly the same except for a negative. So the co-function will have a negative in the numerator. The derivative of arc tangent of u is the derivative of u over 1 plus u squared. Notice once again, the derivative of the inverse cotangent is just the opposite of that, opposite in terms of negative u prime over 1 plus u squared. The derivative of the arc secant of u is u prime over the absolute value of u, square root of u squared minus 1, and the arc cosecant is the opposite, it's the negative of that. So keep in mind the form. So arc sine is the square root, has a square root in the denominator, and the order of subtraction is constant minus u squared. Whereas arc secant, it has a variable outside the radical also, but inside the radical, the order of subtraction is variable minus constant. And the arc tangent does not have a radical. Let's look at some examples. If f of t is arc sine of t squared, then I'll let u be t squared. The derivative of t squared is 2t. Therefore, f prime of t will be 2t over the square root of 1 minus our u squared. T squared squared is t to the fourth. And there we go. The derivative of arc secant of 2x, well, 2x is our inside, so we'll let u be 2x. The derivative is then 2. Arc secant has the form, derivative of u, 2, over u in absolute values, square root of u squared minus 1, so we simplify the 2 here, and a 2 in absolute values will cancel out and give us a 1, absolute value of x in the denominator, 4x squared minus 1 under the radical also in the denominator. This is just the chain rule when we're doing these u substitutions. It's just thinking of inside and outside. The derivative of the arc tangent of the square root of x. We're going to let u be the square root of x. And we've had this function so many times. The derivative of the square root of x is 1/2 x to the negative 1/2. But by now, hopefully you can automatically see it as 1 over 2 square root of x. If not, write it out. If you need to pause, make sure I'm right, then please do so. But our derivative, assuming that this derivative of u is correct, I don't know why I've been using u prime previously and I put du here. Probably a bit of a gap in writing my examples. The derivative of f is u prime, or du, over 1 plus u squared. Well, when we have a fraction in the numerator, we can float that denominator down into the main fraction as long as we're multiplying by a 1 plus x in parentheses. Here, when we square root x and then square it, we'll get x back. If h of x equals x squared times the arc tangent of 5x, we have to use the product rule. I consider x squared to be my first function and the arc tangent of 5x to be my second. So we have first, derivative of second. The derivative of arc tangent of 5x is the derivative of 5x, which is 5, over 1 plus 5x all squared, so that's 25x squared. So first derivative is second, plus second, the arc tangent of 5x, times the derivative of the first. Derivative of x squared, 2x. If you want to clean it up a little bit, this x squared is over 1, so we can multiply it by the numerator to get 5x squared over 1 plus 25x squared plus 2x arctangent of 5x. For our last example, if f of x equals arc sine of x plus arc cosine of x, keep in mind with x, the derivative of x is just 1. So the derivative of arc sine of x is 1 over the square root of 1 minus x squared. But the derivative of arc cosine is the exact same thing, only with a negative. Therefore, when I add these two derivatives, I get 0. Something a little challenging looking can have a very simplistic derivative. That's it for differentiation involving inverse trigonometric functions. Thanks for listening.